Welcome to part 10 of the Java Learning Series by TECHMargadarshi. In this part, we'll explore the set interface in Java, which is used to store unique elements without duplicates. We'll understand how set works and learn popular implementations like HashSet, LinkedHashSet, and TreeSet. This session will help you choose the right set implementation for real world applications. Let's get started. Now let's start by understanding the set interface in Java. Set is a part of the Java collection framework and is mainly used to store unique elements only. This means duplicate values are not allowed. If you try to add a duplicate, Java simply ignores it. Set belongs to the java.util package and extends the collection interface as shown in the hierarchy diagram. Unlike list, set does not support index-based access and generally does not guarantee insertion order, except in linked hash set. Most set implementations allow only one null value. We use set when data uniqueness is important, such as storing usernames, email IDs, roll numbers, or tags. Common implementations of set include HashSet, linked HashSet, and TreeSet, which we'll explore in detail next. Now let's understand HashSet in Java. HashSet is a class that implements the set interface and is used to store unique elements only. It is part of the java.util package. HashSet does not maintain any insertion order, meaning elements may appear in any order when printed. It does not allow duplicate elements and permits only one null value. Internally, HashSet uses a hash table data structure, which makes operations like add, remove, and search very fast, usually in constant time. HashSet does not support index-based access like list, and it is not thread safe by default. We generally use HashSet when we need uniqueness along with high performance, such as storing unique IDs, email addresses, or tags. Commonly used HashSet methods include add to insert elements, remove to delete elements, contains to check existence, size to get the number of elements, is empty to check whether the set is empty, and clear to remove all elements. Let's look at a simple HashSet example in Java. First, we import the HashSet class from the java.util package. Inside the main method, we create a HashSet of string type. Next, we add elements to the HashSet. Here, Java and Python are added successfully. When we try to add Java again, it is ignored because HashSet does not allow duplicate values. We also add a null value. HashSet allows only one null element. When we print the HashSet, the elements may appear in any order because HashSet does not maintain insertion order. Using the contains method, we check whether Java exists in the set, which returns true. Then, we remove the element Python using the remove method. Finally, the size method returns the total number of unique elements present in the hash set. This example clearly shows how HashSet ensures uniqueness and provides fast performance. Now let's understand linked HashSet in Java. Linked HashSet is a class that implements the set interface and is very similar to HashSet, with one important difference. It maintains the insertion order of elements. It belongs to the java.util package and does not allow duplicate elements. If we try to add a duplicate value, it will be ignored. Linked HashSet also allows only one null value, just like HashSet. Internally, linked HashSet uses a combination of a hash table and a doubly linked list. This is how it maintains the order in which elements are added. Because of this extra ordering mechanism, linked HashSet is slightly slower than HashSet, but still offers good performance. Linked HashSet is not thread safe by default, so synchronization is needed in multi-threaded environments. We should use linked HashSet when we need both uniqueness and insertion order, such as maintaining logs, history, or ordered records. Now let's look at a simple linked hash set code example to understand how it works in practice. First, we import the linked hash set class from the java.util package. Inside the main method, we create a linked hash set of type string. We then add elements like Java, Python, and C++. When we try to add Java again, it is ignored because linked hash set does not allow duplicate values. We also add a null value. Linked hash set allows only one null element. When we print the set, notice that the output maintains the insertion order Java, Python, C++, and null. Next, we remove the element Python, and the updated set reflect the change while keeping the order intact. Finally, we use the contains method to check if Java exists in the set, and the size method to find the total number of elements. This example clearly shows how linked hash set ensures uniqueness while preserving insertion order. Now let's understand TreeSet in Java and how it differs from HashSet and linked hash set. TreeSet is a class that implements the sorted set and navigable set interfaces. Its main feature is that it stores elements in sorted order. By default, this sorting is natural. Numbers are stored in ascending order, and strings are stored alphabetically. TreeSet does not allow duplicate elements. If you try to add a duplicate value, it is simply ignored. Unlike HashSet and linked HashSet, TreeSet does not allow null values because it needs to compare elements for sorting, and adding null will result in a null pointer exception. Internally, TreeSet uses a red black tree, which is a self balancing binary search tree. Because of this, operations like add, remove, and search take O of log n time, making it slightly slower than HashSet. TreeSet also provides powerful navigation methods such as first, last, higher, and lower, which help in range based and sorted data operations. TreeSet is best used when you need unique data that must always remain sorted, such as rankings, leaderboards, or ordered reports. Let's look at a simple TreeSet example to understand how sorting and navigation work in practice. First, we import TreeSet from the java.util package and create a TreeSet of integer type. When we add elements like 30, 10, and 20, the TreeSet automatically stores them in ascending sorted order. Even though we try to add the value 10 twice, the duplicate is ignored because TreeSet does not allow duplicate elements. When we print the TreeSet, the output is 10, 20, 30, showing that sorting happens automatically. The first method returns the smallest element in the set, which is 10, and the last method returns the largest element, which is 30. The higher 20 method gives the next higher element after 20, which is 30, and lower 20 returns the next lower element, which is 10. This example clearly shows how TreeSet maintains sorted, unique data and provides powerful navigation methods for working with ordered collections. In this part, we explored the set interface and its key implementations like HashSet, linked HashSet, and TreeSet. We learned how set ensures uniqueness, handles ordering, and supports sorting based on different use cases. Practicing these examples will help you clearly understand when and where to use each set type. Stay connected with Tech Margadarshi for the next part of our Java learning series. Keep learning, keep practicing, and we'll see you in next session.